Hi, this is Ms. Park, and this video is our last transformation called stretches. So here we go. We've seen this before. We've seen this in a previous video. It's just the f of x. We don't have an equation for this one, just a bunch of points that are connected. This is the graph of f of x. So now it's asking us to graph 3f of x on the same axis. So 3f of x, so I'll just remind you that f of x is y. So if there's a 3 on the outside, means you take the output of this function, which is y, and multiply the output by 3. So what we end up having is every point xy, so I'm just going to find, I'll just write the mapping rule on the side here. So xy is going to become, now this 3 is affecting the output because it's outside the f of x. So the input, which is x, is unaffected, stays the same. And then the y will be multiplied by 3. So what happens when we multiply the y's by 3? This is the point -4, +2. So if I multiply the y by 3, if I apply the mapping rule, I'm going to get -4, 6. So that point is transformed to there. The point 0, -1 will be transformed to 0, -3. Multiplying the y's by 3. And I'm just going to connect these as I go so I don't lose track of the points I'm putting on here. Okay, this is the point 4, 1. That's going to become 4, 3. And this is the point 6, -3. That point's going to become 6, -9. So I am going to end up going off this grid. So that's 1, 2, 3, 4, 5, 6, 7, 8, and I'll just go one more over here to there. Okay, and you can see similar shape, but not exactly. It's actually been stretched. Okay, it's been stretched. So this is the graph y equals 3f of x. And we say that it has been stretched vertically, so vertically stretched by a factor of 3. Vertically stretched by a factor of 3. So remember I told you every time we do graphing transformations, we're always going to write the words in English first. We're going to write the transformations in words, and then we're going to do the other stuff. So let's look at the next one. So the next one is 0.5 f of x. So again, it's going to be, let me switch pens. So for the next one, xy is going to become, x is going to stay the same, and then we're going to multiply all the y's by 0.5. So the point -4, 2 becomes -4, 1. The point 0, -1 because 0, -1/2. 0, -0.5 or a half. Okay, the point 4, 1 becomes 4, 1/2. And the point 6, -3 becomes 6, -1.5 or -1.5. And I'm connecting these dots. So what has happened here, 0.5 f of x. So what has happened here is that the y's are not growing as quickly because we keep multiplying them by a half. So that makes it look like the new graph, the green one, is compressed. Now, in our course, we're only going to use the word stretch. So because the word compressed is the opposite of stretch, and sometimes when we say by a factor of, it'll become confusing. So here's what we're going to say. We're going to say that this is vertically stretched by a factor of 0.5. Now, the fact that this factor is less than 1, that tells you that that stretch is going to look like a compression. It looks like it's gotten smaller, okay, smaller this way. But if the stretch factor is bigger than 1, then you know that it has grown this way. It has been stretched bigger. okay? But we're always going to use the word stretch. All right, we're not going to say compressed by a factor of 3. Think of it, if we say compressed by a factor of 3 or compressed by a factor of 0.5, do we know, is that very clear as to whether it's getting bigger or smaller vertically? So it's just an English thing. So we're always going to use the word stretch. Okay, now we had vertical stretches with the parabolas last year, and it was this a value. We know about the a value, right? When you had an a here that was bigger than 1, your parabola was stretched vertically. It became narrow and long and high. And when this number is less than 1, it became wide because it couldn't grow as high vertically. So what we didn't have last year is anything on the inside of the x squared. And so this is brand new. I'm going to write here, this is new. Grade 11. So in grade 11, we have something called a horizontal stretch. This one's going to be a little bit more challenging. So we'll listen carefully, okay? Here's a graph of f of x. It's different from this one, but it's, again, we don't have the equation, we just have the points. Let's graph f of 2x on the same axes. Now, f of 2x, let's think about what happened with the reflections and with the translations when there was something horizontal. So horizontal because we're affecting the x's or the input. So it's going to be something horizontal. When something's happening that's horizontal, it does not change the vertical. Just like when something's happening vertically, it does not affect the horizontal. Nothing's moving side to side or changing shape side to side, only vertically. So we're going to leave the y the same. So I'm going to write my mapping rule here. The y is going to stay the same, but now we have to think about what do the x's have to be so that 2 times those x's gives us these y's. So basically 2 times the x's should give us the original x's because I want my y to be the same as the original. So what's going to happen to the x values if I need to double them in order to be my original? So if I'm going to have to double them in order to be my original, that means they're going to be half of what they were originally. If I have this half x and I double it, then I'm going to get f of x, and so I'm going to get the same y's. A little bit hard to process, I know, but hopefully you'll get used to it. So f of 2x, though it appears that it's going to get wider because of that 2, watch what happens. So I'm going to take this point. This is the point -2, 0, and I'm going to apply the mapping rule. So I'm going to get -1, 0. This is the point 0, 4. I'm going to apply the mapping rule. So half of 0 is still 0, and the y doesn't change. So I have this point 0, 4. Let me connect. Then there's this point 4, 0. So half of 4 is 2. So I'm going to have the point 2, 0. And look what happened at my new function. Look what happened to my function. It is not wider, it's actually narrower horizontally, right? That's because each x is cut in half. Each x has been cut in half. And so that is a little bit of a backwards thing when it comes to horizontal stretches. So what I have done here in words, instead of I have stretched this horizontally or horizontally stretched by a factor of 2, that would mean it's wider. What I've done is I've horizontally stretched by a factor of 1/2. All right, and because that 1/2 is smaller than 1, then that stretch by a factor of 1/2 looks like a compression horizontally. Okay, so that's different from this one here. It's kind of backwards. Let's try it again. This one is 0.5x or 1/2 x. All right. If I want to find the x's, if I want the x's so that when I cut them in half, I'm going to get the original x's so that to produce the same y. What do the x's have to start out being? So that whatever I put in here, when I take half of that, I'm going to get x. So that ends up being 2x. All right, so let me show you the graph now. So -2, 0 becomes -4, 0. 0, 4 stays 0, 4. Let me connect the dots. All right, and 4, 0 becomes 8, 0. All right. Okay, let's label these two equations. So this is y equals f of 2x. My new one is y equals f of 0.5x. Right? And my new one looks like it has been stretched bigger horizontally, whereas my first one looks like it was compressed horizontally. But in both cases, we're always saying stretched. So I'm going to say here horizontally stretched by a factor not of 1/2, not of 0.5, but 2, because they have been multiplied by 2. The x's have been multiplied by 2. Here, stretched by a factor of half means all the x's have been multiplied by half, which makes it look compressed. All right, so it's going to take a little bit of getting used to, I recognize that. Here's a little table that sums it up for you. It says, when the number is in front, it's a vertical stretch, right? That's our a value that we know from before, okay? If that a value is greater than 1, it's expanded vertically. If the a value is between 0 and 1, it's compressed vertically. All right, we're just always going to use the word stretch, but this tells you what it looks like. All right, if it horizontally stretched, so if you have the a value on the inside, and actually we're not, when we move forward, you're going to see we're not going to confuse ourselves by calling them both a. We're going to start using the letter k for the inside. All right, but on this page, they're using a for both. All right, so if the k is a number that's less than 1, so like the half in this example, then that graph is going to look like it's expanded horizontally, gone bigger. And if a is greater than 1, like that 2, the graph is going to look like it's compressed horizontally, right? But again, we're always going to use the word stretch. All right, so this quick example. All right, here's your y equals f of x. All right, let's go y equals f of x. Compare the graphs of y equals 3f of x, y equals 1/2 f of x, and 3f of 1/2 x. All right, so this is good. This one is good because now this one has a vertical stretch and a horizontal stretch. So what I'm going to do, just so I don't take time in this video, I will write the mapping rules for each one of these. So I'll say this is 1. I'll change pens and say this is 2, and this is 3. Once I write the mapping rules, then it's just a matter of plugging in the original points and getting the new graph. All right, so first one, xy will become, so this 3 is multiplied by the output, so it's multiplied by the y's, and the input is not changing. So this become x and 3y. You can sub in your points, so 0, 0 will become whatever, and 2, 2 will become whatever, and you can graph this function. Okay? Then I'll do number 2. Here we have the x's are changing, so the input is changing, so xy is going to become, the output is not changing, it's just the input, so I'm going to leave my y alone. If we have a 0.5 or a 1/2 on the inside, that means it's a horizontal stretch. But the horizontal stretches are backwards, so that if you have the 1/2 inside, it means that the x's would have to be doubled. So this is going to be 2x. y. And you can draw that graph. And now if we put two types of transformations together, we're going to have something that affects the inputs and something else that affects the outputs. So we'll deal with them one at a time. 1/2 on the inside, that's the same as this one in question 2. 1/2 on the inside means that the x's are multiplied by 2. And 3 on the outside, that means the y's are multiplied by 3. And so you can graph this one too. Just put in all the points of the original, and you can get the graphs of all of those. Okay, thank you for watching.